Hi, let's look at the visual exploration platform for the DQ CDM. We're going to dive right in. Here's an overview, a horizontal icicle chart, and we see a bunch of grouping sets. And this is for some synthetic data that came from Achilles OMOP data model into the DQ CDM. We've got a grouping for condition concept ID, and then that with gender concept or calendar month. One with all four of these: condition concept ID, calendar year, gender concept, age decile. These ones that are light blue, those are part of a bigger grouping set, but don't have a grouping set of their own. We're seeing all of the grouping sets here. Some of them have a bunch more data than others, so we can change the chart to size the cells by the number of observations. And so now we're looking at the ones that have more data. But let's drill down on one of these that has less data. And this is calendar year, gender concept ID, age decile. The measure, here we've got some information about this grouping set here. It's got calendar year, 3 of them. Gender concept, 2 distinct values. Age decile, 6 of them. There's 21 combinations of those 3 dimension values. One measure, and since only one measure, one aggregation, the number of combinations is the same as the number of observations. And for all of those together, this measure is a number of persons with a death by calendar year, by gender, by age decile. So what is this telling us? We've got 7 of these combinations, a combination of calendar year, gender concept, age decile, 7 of them that have one person with a death, 8 that have 2, 2 that have 3, and 4 that have 4. And we can, for this gender, all I've got is the codes. I don't know which gender is which here. But this gender has fewer deaths than this gender in this data. And in the age deciles, what have we got? Well, we don't have that much data for these age deciles, and we've got 1 death in each of those. And you can see less deaths in these, more deaths in that. The data is coming, we can see some sample records from the data. This is sort of the raw data, calendar year, gender concept, the age decile, and the value, and that value represents measure name. And what we're seeing, again, this is a histogram of the value representing that measurement by this aggregation method. This is a count. Well, that's kind of cool. That say you're in a situation where you're trying to bring a new data set into the DQ CDM, this can help you understand what you've got so far. Quite a bit different from PCORNet. Oops, let's go to all of them, where there's just a totally different set of dimensions. And I don't know, should we look at some of these? Here's a BMI group. Interesting that we've got just single dimension. So just each of these values represents 1 BMI group. And here are some statistics on the count. And I don't know exactly what this count is because the name of the measure is sort of inscrutable. But we can see that one of the BMI counts, let's see, looks like this one, is null or missing, and that's got a whole lot of people, like the BMI of 0 to 1, there's only 86 people with that, and this one, less than 0, there are no values for that. So data quality wise, this is looking pretty good, and you can see that the Visualization Explorer can do a little bit of data quality, not just give you an overview. You can begin to see some of the data quality issues just by using this tool. This is mini Sentinel data, so many values we can't see the labels on them. But let's see what happens when we do this. So diagnosis code, DX code type, length of stay, etc. Here's this grouping set that's got A-date, members, records, mean, and standard deviation. So something's kind of strange here. Mean and standard deviation are showing up as dimensions, not as values or as aggregation methods. These could be aggregation methods or types of measures of something. So these numbers do measure something, although it's got, again, an inscrutable label. I have no idea what. But, you know, we've got, you know, for the mean and standard deviation, some sort of value out here. And here's a min of that value. Here's a, first percentile of that value, fifth percentile, or I don't know what these P25, etc. Here's a median. But of the specific values, we've got, you know, actual means out in these dimensions. It might have made more sense to put these as aggregation methods and then these ones as actual dimensions, maybe even just these two. So here's another thing that the visual exploration tool can help with is just understanding how have you structured the data. Is this going to be a good way to get the kind of answers that you want? And if it is, what kind of tools do we need to build so that you can get those answers? Or would it be better to, you know, use the DQ CDM more like the OMOP stuff did, and you know, we can build some stuff that'll make it easier to actually explore it that way. Here, one more. This is phys data. Well, there's only one grouping set here, but it's got a lot of measures. The other data sets had lots of grouping sets, but each of them would only have one or two measures, maybe a few measures, a few more in some of the sets. But here we've got 139 measures, and what? Well, the tool will only show you 5 because it would just be impossible to read and get really slow if it showed you a lot. So the tool's not really set up to show you 139 measures right now. Because again, you know, this may be a really weird way of putting data in the DQ CDM. If it's not, then, you know, the tool should be changed to do a little bit better. But even as the tool is built right now, you can start to see some stuff with this. You can start to see, okay, with my, you know, single grouping set, I've got 55 data elements, 83 issue periods, 6 patient types, and 1 hospital name. So there you go. A brief introduction to the visual exploration platform for the DQ CDM. If you're curious about the DQ CDM and don't actually know what it is, go to the wiki page for the project repository. Thanks for watching.